4 pushover methods are available in the application. This video covers the first and most common, conventional, using a single fixed lateral load pattern. Later videos cover modal pushover analysis, multi-directional, and adaptive. Pushover is layered on top of the gravity-loaded state. The model is brought to equilibrium under gravity load, held constant, and only then is the lateral pattern applied and incremented. Gravity loads and the gravity analysis code need to already be in place before this step. Cursor position matters again here. Place it immediately after the gravity analysis code ends before generating the pushover block. Control node is the node whose displacement is monitored and under displacement control driven as the analysis proceeds. Control DOF is the degree of freedom at that node corresponding to the push direction. Model DOF system sets whether the model is 2D or 3D. This determines how many load components each load command carries. FX, FY, MZ for 2D, or the full 6 components for 3D. Base nodes are entered manually, so the analysis records base reactions. Target displacement is where the analysis stops at the control node, and DOF number of steps sets how many increments that displacement is divided into. Inspect member numbers is optional for individually tracking specific members' response. 3 load pattern types are available. Uniform gives every level equal weight regardless of height. Triangular increases weight linearly with height, a purely geometric distribution, each level's weight equal to its height. Neither of these depends on the structure's dynamic properties. T1 only matters for the code pattern. If a modal analysis has already been run and saved, it's collected automatically. Uniform and triangular don't need it at all. If a modal analysis has already been run and saved, T1 is collected automatically here. Regardless of pattern, the same table is filled in the same way, node number and height, 1 row per loaded node. The per node load is calculated automatically from the pattern equations and shown live next to each row. The distribution doesn't need to be computed by hand. Distribution happens in 2 stages internally. First, the total base shear is split across each unique height according to the pattern's weighting. Second, each level's share is split equally among the nodes at that height, so 4 nodes at one level each receive a quarter of that level's force. Together, these 2 stages guarantee the applied loads sum exactly to the total base shear specified. Solver settings here work the same as gravity analysis. For structures expected to have convergence difficulty near their capacity limit, error handling mode falls back through alternative solution strategies automatically when the primary algorithm fails to converge at a step, rather than stopping the analysis outright. With the distribution table filled in, Generate Refresh TCL builds the pushover code into the preview. Insert TCL into editor adds it to the code editor at the cursor, placed after the gravity analysis code as positioned earlier. Run OpenSees the OS button on the shortcut panel or run OpenSees under Run function to execute the analysis and collect results. Select Pushover Curve from Visualize to plots the base shear versus roof displacement curve from the completed run. Chart title, axis labels, and curve color are all editable here, updating the plot live. Ultimate response, ultimate roof displacement, and ultimate base shear populates automatically once the data is loaded, read directly from the capacity curve. FEMA P695 calculates the FEMA P695 style ultimate displacement and related parameters from the same capacity curve per FEMA P695 and ASCE 41 guidance. Bilinear curve fits and displays the bilinear idealization, the yield point, dy and fy used throughout the rest of the application. Save Results stores these parameters for other analyses in the project to use. Collapse risk assessments, period-based ductility, and the SPO2IDA fragility method's yield point both depend on results being saved here first. Without this step, those later tools have nothing to read. Export PNG saves the plot as an image, Export Excel saves the underlying curve data, and Export PDF generates a full report covering the capacity curve, bilinear idealisation, and FEMA P695 parameters where calculated. Working order, in summary: gravity first, cursor after the gravity block, choose and fill in the load distribution, generate and insert the TCL, and run. Then read and save the results from the pushover curve window.